Lesson for today is steel framing system. At the end of this session, students will be able to identify the type of steel framing system available in the construction industry. Steel can be used for construction of skeleton frames for structures in various sizes, ranging from one story to high-rise. Unlike timber and concrete, steel structures are difficult to cast on site. Therefore, steel structures are fabricated in factories according to the design specifications. This resulted in relatively fast and precision construction similar to precast concrete components. Steel structures may expose and unprotected. However, the strength of steel weakens rapidly with the presence of fire. Therefore, coatings and fire-rated features are required for protection. Steel structure is often used in high-rise, industrial, warehouse, and residential buildings. Larger and high-rise buildings normally use hot-rolled steel section for the frame structure due to higher strength and capability of carrying higher loads. Whereas smaller and lower-rise buildings often use cold-formed thin sheets of galvanized steel section due to lightweight. The photos show several examples of buildings use steel framing system. Steel that is immensely strong. For example, circular bar of 25 mm or 1 inch in diameter, if attached securely to ceiling, could hang 20,000 kg or 20 tons of load. Flexibility. Steel can bend without cracking, so therefore building can flex when pushed to one side by wind or earthquake. Steel has plasticity characteristics. When subjected to a great force, steel will not suddenly crack like glass, but will slowly bend out of shape. This property allows steel building to bend out of shape, deform, thus provide warning and time for residents to escape. Failure in steel frame is not sudden, so therefore steel structure rarely collapse. Steel perform far better in earthquake compared to other materials. However, steel quickly loses its strength when it comes to fire. At 500 degrees Celsius or 930 degrees Fahrenheit, mild steel can lose almost half of its strength. This is what happened to the World Trade Towers when it collapsed in 2001. Hence, steel building must be protected from fire or high temperature. This is usually done by spraying. Steel construction is most often used in number 1, high-rise buildings because of its strength, low weight, and speed of construction. Number 2, industrial buildings. This is because of its ability to create large span spaces at low cost. Number 3, warehouse buildings, because of its ability to create large span space at low cost, similar to the industrial buildings. Number 4, residential buildings. This is because of the availability of technique called light gauge steel constructions. And number 5, temporary structure. This is because of quick setup and removal. There are two types of steel building construction. Steel construction is also called steel fabrications. Number 1, light gauge steel constructions, and number 2, bolted and welded steel construction. Light gauge steel construction is common for residential and small buildings commensurate the magnitude of load to be carried. The concept is similar to panel system in prefabricated timber frame construction. The difference is that galvanized light gauge steel members are used instead of timber to build the panel frame or roof trusses. Galvanized light gauge steel is cold-formed thin sheet of steel bent and shaped to form C-section and leg sections to be used as stud for the construction of partition wall or purlin for roof trusses. The steel sheet is galvanized or zinc-coated to prevent oxidation and corrosion. Cold foam light gauge steel framing is durable, reliable, and cost-effective for small and low-rise buildings. Bolted and welded steel construction is the preferred method for industrial and large buildings commensurate the high magnitude of load to be carried. The size of the components governed by the size of the vehicle for transportations. The steel components used are the hot roll sections such as I-beams or universal column, which is thicker and wider to better withstand loads. Hot roll steel sections are connected and jointed by bolted and welded to form the structural frame. It is suitable for industrial buildings that require large span structure. Example weight of steel frame structure. A single-story building with size 5 meter by 8 meter with 4 columns at the corner, beam spanning between columns, 150 mm thick concrete slab at the top. Therefore, the total structure weight is 800 kg per meter square or equivalent to 32,000 kg or equivalent to 32 tons. However, if used steel instead, with sloping roof covered with corrugated metal sheet with insulation, the total structure weight is only 65 kg per meter square or equivalent to 2,600 kg equivalent to 2.6 tons. In conclusion, the concrete building is over 12 times heavier and this example is for a single-story structures. In multi-story structures, the difference will be less due to flaws in multi-story steel buildings which are built of concrete slab for economic reasons. However, the difference is still significant. Advantages of steel structure. Steel structures have the following advantages. Number 1, super quick to build at site. Because of lots of work can be prefabricated at the factory. Number 2, flexible. Good at resisting dynamic forces such as wind and earthquake. Number 3, wide range of ready-made structural sections are available, such as I-beam, angle, channel, and etc. Number 4, steel can be made to any shape and clad with any materials. Number 5, wide range of joining methods is available such as bolting, welding, and riveting. Steel structures have disadvantages. Number 1, they lose strength at high temperature and susceptible to fire. Number 2, they are prone to corrosion in humid or marine environment. These are the most common shapes of structural steel used in buildings. Number 1, square bars. Number 2, round bars. Number 3, plate bars. Number 4, angle bars. Number 5, channels. The standard channel has the shape of unsymmetrical balance consisting of two flanges on one side. It requires lateral supports to prevent its tendency to buckle. Channels are generally used as parts of build-up section for columns and are also suitable for framing around floor openings, spandrel, and lintels attributed to the absence of flanges on the other side. Number 6, I-beams. Number 7, T-beams. Number 8, H-columns. Number 9, wide flanges. And number 10, Zs. The Z section is another structural form in a letter Z, which is not frequently used in building construction except for fabrication of steel windows and other frames. One-way beam system. Each pair of external columns supports a long spanning beam or girders. And this form of construction is suitable for long, narrow buildings, especially when a column-free space is desired. The absence of column in the interior is an advantage in structures such as car parks, as freedom from obstructions makes for greater and safer maneuverability, besides allowing the layout of the parking space to be altered at any time. Two-way beam system. A two-layer system where beams frame into girders increases floor depth considerably and provide more space for mechanical system. Steel girders span the short axis of a building bay, thus contributing to the lateral stability of the structure. Three-way beam system. This system is used when a large column-free space is required, where long-spanning plate girders or trusses can be used to carry the primary beam, which in turn support a layer of secondary beams. Steel column consists of 5 types. Number 1, struts of 1 or 2 angles. These are used for compression members in roof trusses, light towers, and lattice girders. The two angles of a double strut are riveted together by rivets driven through washers placed between the two angles at interval of 1.2 to 1.8 meters. Number 2, star angles of 2 or 4 connected by batten plate spaced at interval of 1 to 1.2 meter. These are used to support the light loads. Number 3, lattice columns, made up of channels or angles connected by lattice bars, are often used when light loads are to be supported on long columns. Number 4, roll H columns. These are obtainable with depths ranging from 6 inches to 16 inches and are now commonly used instead of built-up columns in steel skeleton construction. Number 5, built-up column. These are usually of H-shaped section formed by a combination of plates and angles although box columns with two or more webs are not uncommonly used in heavy building frames. These are the examples of connection used for steel column to connect two columns with different sizes and to connect column to concrete base. Steel beams may be rolled in the shape of letter I, such as I-beams, channel beams, or angles. The I-beam is the ideal type of steel beams. The vertical portion is the web. They vary in depth and in weight. Girders may be built up of angles and plates riveted together for long spans and for unusual cases of very heavy loadings. There are of two types. Number 1, plate girders. A plate girder is a beam composed of a wide plate known as a web, at the top and bottom of which are riveted angles and plates. The simplest type of plate girder consists of a web and 4 flange angles. If this does not give sufficient flange area, cover plates may be added. The web may be frequently reinforced against buckling by angles riveted to its sides, known as stiffener angles. Number 2, box girders. This is a built-up beam in which more than one web plate is used. Beams and girders may be connected to columns by either seated connections or frame connections. In seated connections, the bottom flange of the beam rests on and is filled riveted to an angle shock riveted to the flange or web of the column. Another angle is filled riveted to the column and to the top flange of the beam. In a frame connection, the web of the beam or girder is connected by angles or by gusset plates to the column. In frame connections, angle seats are usually shock riveted to the columns to hold the beam or girder during erection. Moment connections is also called rigid frame connection, and able to hold the original angle under loading by developing a specified resisting moment, usually by means of plates welded or bolted to the beam flange and the supporting column. Shear connection or simple frame connections are made to resist only shear and are free to rotate under gravity loads. Shear walls or diagonal bracing is required for lateral stability of the structures. Semi-rigid connections assume beam and girder connection possess a limited but non-moment resisting capacity. Open web joists are lightweight, shop fabricated steel members having a truss web. A K-series joist has a web consisting of a single bent bar running in a zigzag pattern between the upper and lower chords. The LH long span and DLH deep long span series joists have heavier web and chord members and are for increased loads and spans. Metal decking are corrugated steel panels used as a working platform during constructions and eventually as formwork for side-cast concrete slab. The decking panels are secured with paddle welds or shear welded through the decking to the supporting steel joists or beams. The panels are fastened to each other along their sides with screws, weld, or button punching standing seams. If the deck is to serve as a structural diaphragm and transfer lateral loads to shear walls, its entire perimeter is welded to steel supports. There are three major types of metal decking. Number 1. Form decking. Serve as a permanent formwork for a reinforced concrete slab until the slab can support itself and its live load. Number 2. Composite decking. Serve as a tensile reinforcement for the concrete slab to which it is bonded with embossed rib pattern. Composite action between the concrete slab and the floor beams or joists can be achieved by welding shear studs through the decking to the supporting beam below. Number 3. Cellular decking is manufactured by welding a corrugated sheet to a flat steel sheet, forming a series of spaces or raceways for electrical or communication wiring. Special cutouts are available for floor outlets. The decking may serve as an acoustic ceiling when the perforated cells are filled with glass fiber. A truss is a structural framework composed of a series of straight members so arranged and fastened together that external loads applied to it will cause only direct stress in the members. The upper and lower members of a truss are called the top chord and bottom chord respectively. The members of the truss which are framed between and join the top and bottom members are called web members. When the external loads act downward and the truss is supported at the ends, the top chord is always in compression and the lower chord always in tension, similar to the upper and lower flange of a beam. The web members are subjected to stresses of either tension or compression. Web members subjected to tensile stresses are called tension web members. Those which are subjected to compression are called compression web members. In certain positions, a web member may be subjected to tension through the action of a load applied at one point, and when applied at another point, that load may produce compression in the member so that at one time it will be subjected to tension and at another time to compression. Such a member designed to resist either tension or compression is called a counterbrace. A member of a truss system which acts only for a particular partial loading and which has zero stress when the truss is completely loaded is called a counter. When a truss is supported at its ends by column, the truss together with its column considered as a unit is called a band. The intersection between two or more members of the truss is called a joint or panel joint, and the distance between two adjacent joints along either the top or bottom chord is known as the panel or panel length. The quadrangular space crossed by an inclined web member is also referred to as a panel. The axes of all members at each joint should always meet at a common point. The span of a roof truss is the distance between the centers of the supports, and its rise is the distance between the apex of the truss and the line joining the points of support. The pitch of a roof truss is the ratio of the rise to the span for a truss symmetrical above its center line. The portion of the roof between two adjacent trusses is called a bay. Types of trusses. Number 1. Complete frame. A complete structure frame or truss is one in which is made up of the minimum number of members required to provide a complete system of triangles, fixing the relative position of a given number of panel joints. If the number of panel points in the given structure and n equals the number of necessary members, therefore the equation is n equals to 2p minus 3. Number 2. Incomplete frames. One in which the number of members is less than the required by the equation given above. Number 3. Redundant frame. A redundant frame is one which contains more members than that required by the equation given above. This is several examples of roof trusses form. Simple truss is a truss supported at each end point. Overhanging end span is a truss supported at one end joint and other joint not an end joint. Cantilever span is a truss where the entire support is at one end only. This is several examples of roof trusses wet bracing system. Another examples of roof trusses. Rigid frames consist of two columns and a beam or girder that are rigidly connected at their joints. Applied loads produce axial, bending, and shear forces in all members of the frame since the rigid joints restrain the ends of the members from rotating freely. In addition, vertical loads cause a rigid frame to develop horizontal truss at its base. A rigid frame is statically indeterminate and rigid only in its plane. The framing system can be stiffened against horizontal forces in three methods. Number 1. The structure is composed of rigid frames which may comprise some hinge joints, but there must be sufficient rigid joints to ensure that none of the nodes of the frame is free to move sideways. The members may be straight or curved, and a variety of shapes may be chosen for such frame structure. Number 2. A bracing system which consists of a triangulated framework of roll section will hold the joints together and further strengthen the framework against lateral loads. The center lines of members converging at a joint should intersect at one point. The joints themselves are conventionally assumed to be hinged so that the members are either ties or struts, loaded purely in tension or compression respectively. However, the overall bracing effects of a lattice system can be enhanced by constructing it with stiff members and rigid joints. Number 3. Finally, shear walls in the form of more or less solid diaphragms, usually of reinforced concrete, transmit the wind and earthquake forces by shear and bending. If a high-rise building is of suitably compact shape on plan, such as circular, square, and not too narrow a rectangle, the external columns can be structurally merged with the external lattice bracing or with spandrel girder so as to form a vast rigid tube. This stiffening system is particularly effective and economical. This is due not only to the optimum distribution of the bracing, but also more particularly to the cooperation of all the columns and bracing or spandrel girders in the external walls. The John Hancock Center at Chicago employs the tube in its framing system. In this 335-meter high, 100-story building, all the horizontal forces are transmitted through external bracing, whereby a substantial saving has been achieved in comparison with a bracing system located in the interior. The external lattice members form a distinctive architectural feature. Steel shapes can be joined in the building frame, riveting, bolting, and welding. A rivet is a short pin of malleable metals such as iron, steel, or copper with a head at one end, used to unite two metal plates by passing it through a hole in both plates and then hammering down the point for a second head. In structural riveting, a hot steel rivet with a form head is inserted in holes through two members to be joined. Its head is then held with a hand hammer with a cup-shaped depression, while a pneumatic hammer drives a rivet set repeatedly against the other end to form a second head. The rivet shrinks as it cools, drawing members tightly together. The bolts commonly used in steel frame construction falls into two general categories. Number 1, carbon steel bolts or common bolts are similar to the ordinary machine bolts. Carbon steel is steel having no specified minimum content of alloying elements, minimum copper content not exceeding 0.4%. Number 2, high-strength bolts are bolts made of either high-strength carbon steel or quenched and tempered alloy steel. Tempered meaning heat-treated during manufacture to develop the necessary strength. It is usually tightened using pneumatic or electric impact wrench. Welding has become fully accepted as a means of joining steel structures members in building because it has the inherent advantage of fusing the metals to be joined, thereby simplifying connections and fabricating operations. The fusion welding process employs an electric arc wherein energy in the form of heat is supplied by establishing an arc between the base or parent metal, such as the parts to be joined, and a metal electrode. As the arc is formed, tremendous heat is concentrated at the point of welding. Instantly, the materials are at melting point temperature. The parent metal melts in a small pool and additional metal supplied by the electrode is transferred through the arc and deposited in the pool. As the electrode continues along the joint, the molten metal left behind solidifies to form the weld. Most welding is done with coated electrodes. The function of the coating is to form a gaseous shield which protects the arc and molten metal from contact with the air. Oxide and nitrites resulting from contact with the air tend to produce brittle welds. The coating also forms a slack fuse shield which floats above the molten metal, protecting it from the atmosphere. The slag is easily removed after the weld has cooled. Fillet weld is of approximately triangular section joining two surfaces approximately at right angles to each other. The fillet weld is the most common type of weld used in structural work. Groove weld is made by depositing filler material in a groove between two members to be joined. The standard types of groove are square, V, bevel, and J. With the exception of the square groove, all grooves may be either single or double. Plug or slot weld is made of a circular hole or an elongated hole in one member of a lap joint, joining that member to the portion of the surface of the other members that is exposed through the hole. There are four positions in welding. In order of economy, there are the flat, horizontal, vertical, and overhead position. Overhead weld, which is the most difficult, should be avoided whenever possible. The three most common joints used in structural works are the butt, T, and lap joints. Other types are the edge and corner joints. Fillet welds are applicable to T, lap, and corner joints. Groove welds are applicable to all joints with the exception of lap joints. This is an example of connection between steel column and beam using bolt and nut facilitated with angle cleat welded to the column and beam. This is an example of connection between steel beam using bolt and nut facilitated with fish plates and wet plates. This is an example of connection between steel column and concrete base using bolt. This is an example of connection between steel column and roof truss using bolt and weld. The application of steel structure in building could provide health benefit that potentially could be deteriorated from the usage of timber, such as number 1, allergy from wood and spore. Number 2, insects such as termites and ants. Number 3, rodents and mice. Number 4, dangerous arsenic used for wood treatment. The use of steel structure promotes environmental benefits such as number 1, recycling. Number 2, minimizing timber usage. And number 3, eliminating waste of materials. The use of steel structure promotes time saving due to number 1, 200% faster than timber construction, and number 2, 250% faster than masonry construction. Another advantages of steel including number 1, steel is the most accurate components compared to timber and mason due to workers' inaccuracy. Number 2, steel components are pre-engineered. Number 3, no squeaky floors compared to timber. Number 4, greater span compared to timber and concrete. And number 5, higher strength to weight ratio. This is the typical building process when it comes to steel structure, from modeling to production to fabrication, then erection and installation of windows, doors and cladding. Light gauge steel framing system consists of structural frames fabricated using cold form steel sections. They can be used throughout the structure, including load-bearing exterior walls, non-load-bearing interior walls, floor joists, curtain walls, and roof trusses. Light gauge steel frame construction is an innovative and reliable construction method which is broadly used in the world and has surpassed wood frame construction in many design and construction aspects. It offers several advantages such as buildability, strength, design flexibility, sustainability, and light in weight, which make it easy to handle and hence increase speed, safety, and quality of construction. Nonetheless, it is easily influenced by fire. That is why fire protection coating shall be provided. Light gauge steel frames elements are manufactured from structural steel sheet that form into strong C or Z or S shapes which are able to support heavy loads. The light gauge steel is also called cold form steel, which comes from the process by which steel members are formed. The strength and flexibility of light gauge steel frame has led to increased spans, custom openings, curved wall, and different external facade treatments. These characteristics make it versatile construction material. The elements of light gauge steel frame members need to be galvanized with zinc, aluminum, or combination thereof in order to provide long-term protection against corrosion. Light gauge steel members are usually joined with self-drilling, self-tapping screws, which drill their own holes and form helical threads in the hole as they are driven. Welding is often employed to assemble panels of light gauge steel framing that are prefabricated in a factory, and it is sometimes used on the building site where particularly strong connections are needed. The photo shows the stiffener used to strengthen the steel members. The photo shows the steel floor system using steel joist. This is an example of inline framing system in which all vertical and horizontal members that carry load are aligned in arrangement of layout. This is an example of typical component of steel structure inline framing system. The photo shows examples of building using light gauge steel structures. The light gauge steel structure used can be covered or hide with wall cladding. Insulation could be applied within the light gauge steel frame for fire and sound insulation or protection. This is an example of electrical wiring installation within the light gauge steel frame. The photos show the roof framing using light gauge steel structure or components. This is the typical roof component when it comes to light gauge steel framing system. This is the rafter to ceiling joist to wall connection system without web stiffener and alternative manufactured connector. This is the ridge member connection system using clip angle and screw. In terms of fire safety, steel will not easily burn. However, steel will eventually lose strength and stiffness over time when exposed to fire due to high heat conducting conducting value which will affect its performance. At 600 degrees Celsius, strength of steel decreased by half. Therefore, steel structures require protection such as coating and insulation. These are the factors that must be taken into consideration in terms of fire safety when designing buildings with steel structure. Coating provides smooth finishing looks. Thus, no additional painting required, and the spray coating can provide 4-hour fire protection before fail. Therefore, this is very economical. Insulation installed within the frame also could provide extra hour of protection. This is the comparison between IBS steel framing system and conventional brick wall. Several advantages of IBS over brick wall such as number 1, does not require reinforced concrete frame. Number 2, the wall itself is load bearing. Number 3, reduction in thickness of wall. Number 4, lighter in weight, thus reduce the dead load. Number 5, does not require plastering. Number 6, faster completion. And number 7, dry construction. That's all for the lesson this time, and thank you very much.